Okay, so for Unit 5 skill review, we're going to start with identifying some of the rules for exponents. So if we look at this, we've got x squared times x to the third. So what does that mean? That means that we have 2 copies of x here, and then we have 3 copies of x here, and we can represent it like this. And so what's the solution? Well, we've got 1, 2, 3, 4, 5 copies of x, so we've got x to the 5th. So what rule can we get from that? We have 2 and we have 3. We added them together and we got 5. So we can say that we're going to add powers. So when we've got it as it's written there, we can add powers. All right, the next one. We've got x to the 5th over x, or divided by x squared. So x to the 5th can be represented this way, 1, 2, 3, 4, 5 x's divided by 1, 2 x's. Okay, well, anything divided by itself equals 1. So we know that this can divide to be 1 and this can divide to be 1. Sometimes you might hear it called canceling. It's really just dividing to 1 so that we don't see it anymore. So what we have left are 3 x's and they're all in the top. So we can write x to the third. So how did we get from x to the 5th over x to the 2nd and end up with x to the 3rd? Well, we subtracted those exponents. So we are going to subtract powers when you're given a fraction like that. Okay, now we have a power raised to a power. So x squared cubed. Well, what that really means is we've got x squared, which can be represented like this, x times x, but we have 3 copies of that. So x times x times x times x times x times x. And now we look at it and we can see that altogether what we have are 6 copies of x. So x to the 6th. How did we take that 2 and that 3 and make it into a 6? Well, we multiplied our powers. So in this example, we will multiply our powers. Oh, and I should have started with number 4, but put a little star next to number 4. Number 4 is 4th on the list, but really it's probably the most, I wouldn't say most important, but it is the easiest one to spot. And when anything is to a 0 power, that just tells us that there are 0 x's. Okay, so if there are 0 x's, that doesn't mean that x disappeared. I mean, there's still the ability to have an x in there. So anytime that you have something to the 0 power, it becomes 1. Okay, so this is always a 1. So if you have some huge number inside of parentheses and it's all to the 0 power, it becomes 1. Okay, number 5, we have x to the negative third. So with that negative exponent, we are going to move, what it's going to look like is we're going to have 1 over x times x times x. So our 3 x's are in the denominator. When it was that negative exponent, we moved it to the denominator, from the numerator to the denominator. If it had been in the denominator already, we would have moved it to the numerator. So let's go ahead and write how that looks written without a negative exponent. It's 1 over x to the third. And our rule for that is you're always going to move a negative exponent up or down. So wherever it is, you're going to move it to the other side. Then we've got 4x to the third squared. So that whole expression is squared. So we're looking at this and it's telling us we have 2 copies of that expression. So what I really have is 4x times x times x. So that's 4x to the 4 times x to the third. But I've got 2 copies of that. So I'm going to write it again. So these two things say the same thing, and now I can just do some basic multiplication there. 4 times 4 is 16. And my x's, how many do I have? I have 3 here, 1, 2, 3, and 3 here, 1, 2, 3, so that's 4, 5, 6. I have x to the 6. So We can remember that up here from rule number 3, a power to a power. We can just multiply those, or I just counted them up. I like to write them all out and count them up. But the important thing about this rule is that we remember to square each term inside those parentheses. You can't just do it to part of it and forget for the rest of it. Write it all out if you need to. Go straight to the rule if you need to, but make sure that you do it to each and every term. And then the final rule is basically, it's very similar to that one. It's kind of the same thing, but we've got this expression x squared divided by 4y, and it's all to the third power. So that means that this whole expression I have 3 copies of. So I'm going to put my x, and that's over 4y, but I need 3 copies of that. All right, so now on the top, across the top, I know I've got 1, 2, 3, 4, 5, 6 x's. And on my bottom, I've got 4 times 4 is 16, and 16 times 4 is 64. And then y times y times y, I have 3 copies of that y. Okay, so the same as I did in number 6, what I really did is if I looked at it, I cubed every single term inside that expression, right? So I took my 3 and I cubed the x squared. I took that 3 and I distributed it down. I cubed 4 and I cubed the y. So we're going to remember to cube each term. Again, you can't just pick and choose the easy ones, or some of them you have to do every single term. Okay, let's see. How do I move this? Do I just... Boop. Okay, so now that we've done that, how do we know when we're done? How do we know when we're finished? What we're going to do is we're going to follow these 3 basic rules of thumb here. When you are finished, there will be no negative exponents. So all of your exponents are going to be positive. You will have moved them to the top or the bottom according to whatever it was needed to happen. There's not more than one of each variable. So there's only one x, it can be in the top or the bottom. There's only one y, it can be in the top or the bottom, or any variable, just so long as there's only one of them to represent. And then all numbers are completely multiplied out or reduced down. So you've simplified your numbers as much as you can. So no negatives, not more than one of each variable, and it is completely reduced, however, to the most exact that you can make it. So we're going to do a couple of these together. Let's start with this first one. Here we go. So I'm going to write it out. I like to write it out into all the different parts. So the first thing I'm going to look at is this -4. I'm going to write that down. And I'm going to do my whole numbers first. And I have a 2 over there, so I'm going to do my times 2. And now I'm going to look at my x values. Well, I have 3 x's. And now I have 5 x's. 1, 2, 3, 4, 5. And those x's aren't necessarily stuck with the numbers. You can move them around. They can. The associative property tells us that we can change the order that they're in. We can move them around. Well, I know how to do a -4 times 2. That's going to give me -8. And now I could have gone straight to the rule, which was that number 1 where I just added my powers, or I can count up all my x's individually, which is what I like to do. So I've got 1, 2, 3, 4, 5, 6, 7, 8 x's. So I am going to say that my answer is -8 times x to the 8th power. And if I looked at that, that is the same thing as had I used the rule. So I'd be multiplying those, and then I would add my powers, and 3 times 5 is indeed 8. Our next one. It looks a little bit different because we've got that fraction bar, but it really doesn't change anything on the way that we're gonna proceed. I'm gonna take my whole numbers first, and I have my -9 divided by 3. So I know that negative 9 divided by 3 is going to give me negative 3, so I'll start by writing that. And now those are finished. I don't have to deal with those anymore. I see that I have 5 copies of x on top. 1, 2, 3, 4, 5. And I have 8 copies of y. 1, 2, 3, 4, 5, 6, 7, 8. I moved on the other side. Sorry about that. And then on the bottom, that 3 has already been taken care of. So I've got 2 copies of x, and I've got 4 copies of y. Now I am just going to cancel or divide them to be 1. I know that those cancel with those. Those get rid of those. So now all I need to do is count up what I have left. Well, I still have that negative 3. Nothing happened there. And on the top, I have 1, 2, 3 x's. So I have 3 copies of x, or x to the third. And I have 1, 2, 3, 4 copies of y. So y to the fourth. And I've eliminated everything in the bottom, which is what I wanted to do because I only wanted to have x represented once and y represented once. So I'm going to call this done. It is the simplest number there. I have each represented only once, and there are no negative exponents. So moving on to the next bit. Let's see, we have, oh, okay. Where's my draw? There we go. We have this term, and it's squared. So remember, our rules tell us that you have to square every term in there. And I like to write that out by just knowing that I have 2 copies of this. So I know I've got negative 6, x, x, and y, y, y. But I have 2 copies of that. So I've got another negative 6, x, x, y, y, y. Okay, so looking at that, the first thing I'm going to do is I'm going to deal with my whole numbers. So I have negative 6 times negative 6. A negative and a negative is going to yield a positive. 6 times 6 is 36. There we go. And how many copies of x do I have? Well, I have 1, 2, 3, 4. So I have x to the fourth. And as far as y's go, I have 6 copies of y. So I'm going to call that my final answer. I've got my numbers as simplified as I can. X and y are both represented only one time, and there are no negative exponents. So that takes care of the front, and then on the back, students will complete, Students will complete the next 6 problems. Get to page number 2. There we go. And so the only thing left on this is the skill for simplifying radical expressions. So we are going to do number 1 and number 14 because they're numbered crazy. We're going to do number 1 and number 14. And how we're going to do that is we're going to think about what we need to simplify this. Well, since we're dealing with square roots, we're going to want to deal with perfect squares. So if I remember my perfect squares, I know that 2 squared is 4, 3 squared is 9, 4 squared is 16, and on and on and on. And so what I want to do is I want to look at a number that is in my category of perfect squares, but is also going to be a factor of 90, because that's the number I'm working with. So if I think about it, I can see right away that 9 is a factor of that. So I know that I can break up my square root of 90. I can break that up in the 2 factors, square root of 9 and square root of 10. And the square root of 9, well, 9 is on my list of perfect squares, so I know already that that turns into a 3. But my square root of 10, there's nothing I can really do to that to make it a nice, pretty number. So we're going to just keep it as is and say 3 times the square root of 10. And that's as far as we're going to take it. And you're going to want to use that same kind of technique when you're doing the cube root. But with the cube root, we can't use those perfect squares because they don't apply. That's not what's important here. Our cube roots, we're going to look at 2 cubed, which is 8. And we're going to look at 3 cubed, which is 27. Okay, let's go ahead and do 4 cubed, which is 64. And you can go on and on and on and use whichever ones that you need according to the problem you're working with. But for right now, we're going to look at this category of number, and we're trying to find something on this list that is also a factor of 135. And you can use your calculator, or if you're good at, dividing things out really quickly, you can do that. And I look at it and I'm going to say that 27 is a factor of 135, because if I take 27 and I multiply it by 5, I will indeed get 135. So I'm going to write that as the cube root of 27 times the cubed root of 5. And I know that equals that cubed root of 135. Well, I know from looking at my list that this is 3. And the other one, I can't make any prettier or any cleaner, so I'm going to go ahead and keep it like that. So 3 times the cube root of 5. Okay, so just to make it really clear, you're going to be doing that again with your 4th roots and your 5th roots. So those next 2 columns. But you have to go from those perfect numbers first. So we're going to look at, for the 4th roots, well, what is 2 to the 4th? Well, 2 times 2 times 2 times 2 is 16. And let's try 3. 3 to the 4th, 3 times 3 times 3 times 3 is 81. And you can go on and on as far as you need, but I don't think you're going to need anything larger than either of those. And what you're going to check for is you're going to check to see if these numbers are factors of what you're trying to simplify. And once you find that, then you can divide it out, and you'll be given 2 factors, and one of them will be able to reduce into that nice pretty form. So if we're looking, those are my 4th roots. Let's give an example of a couple 5th roots so that you can have those to look at too. So 2 to the 5th, so 2 times 2 times 2 times 2 times 2 gives me 32. And let's say 3 to the 5th, and again, I don't think you'll need anything higher than that for our purposes today, is 243. You could have gotten that from a calculator. You could have done it by hand. You can do it in your head if you're awesome at doing things like that in your head. So I'm looking at these numbers, and I'm trying to find one of these type of numbers that is also a factor of 64. So these go with these, and these go into this column. But you're going to use that same method. You're going to look for one of those perfect numbers that's a factor of what you're trying to simplify. You're going to use the 2 factors together, simplify what you can, combine what you can, and if it's not something that is one of those perfect numbers, you're going to want to leave it just as it is, because you will end up getting, if you try it in your calculator, you're going to get a decimal or something that needs rounding. That's not very exact, so we're going to leave it like that. And that is how you do everything on this particular part.